Hey, this is Don from Padlock Technologies again with another video. This time is going to be part two of BGP EVPN service provider style. If you didn't see the first video, that was EVPN point to point. I'm going to put a video over here somewhere to that video. You want to watch that and get a little taste of what BGP EVPN service provider style is. Go ahead and watch that video. But today we're going to talk about VLAN based EVPN. This is one of the simplest setups because the configuration's not that hard once you have, your BGP adjacencies and all that stuff up for the AFI, sub-AFIs. You don't know what that is. AFI, address family, IPv4, sub-AFI, unicast, okay? And that's for anybody that's studying for your CCNP or CCIE enterprise. When they say AFI, sub-AFI, that's what they mean. So we're going to go to the lab now, and I'm going to show you VLAN-based EVPN. Let's go here now. All right, so now we in the lab here. Now, I did get a question about this lab. Now, I did not create this lab out of thin air. There is a very great teacher, CCDE teacher named Orhan. Now, I'm also subscribed to his content, and I actually have a subscription to his courses. And he helped me a lot, learned a lot of things because he goes very in depth from a theory perspective, like really deep into the protocol. So shout out to him. I basically recreated his picture, and this is where this lab came from. I think this is like the NPLS all-in-one lab. So now that that's out the way, what we're going to focus on here is this EVPN single home. So this one, these in yellow. So we got customer H that we're working on today. So what we're going to do is I'm going to show you, it's very simple to do VLAN base EVPN. Now we're going to introduce the concept of a bridge domain in this one because we don't have a bridge domain technically in the point-to-point version of EVPN. So I'm just going to show you router 6 here. I got a lot of, let me get rid of that. That's a little bit too much for me. So let's go to router 6. And the only real difference here with the VLAN base, if I go show run section L2 VPN, I'm going to highlight it right. What am I doing here? I'm going to highlight this here. All right. This is the only thing you need to do, right? Once you set up the rest of the stuff. Again, watch the first video to see how you set up BGP EVPN from the jump, right? This is just an additional step to do the VLAN base. So basically what you're going to do is L2 EVPN instance, whatever the instance number is, and VLAN base. The only thing else you have to do is do the RD because the RD makes the route, unique. Everything else kind of gets auto-populated. Just like if you do it on the Nexus platform, you don't really have to do RT values because they get auto-generated, right? So this is the same concept, auto-generated. Now, once you finish doing that, really all you have to do is go to the interface and configure your service instance. So I believe router 6 has 5 and 4. So I'll just show you G5 here. So we got a service instance 8 internet. We're not doing any encapsulation, so I don't have to look for a .1Q tag. And then we're forwarding the CDP so we can see CDP neighborships. Now, what happens when we do this version of BGP EVPN? Now, if you remember in the BGP EVPN table, and I know I'm saying BGP EVPN a lot, but it's just to remind you what we're actually doing. If you look into the table, we only saw router type 1, which was the router advertised just to say, hey, I'm a part of this EVPN, right? It's the router type. Now, what we're going to see is twos, and twos are your MAC to IP bindings. Now, in this one, you won't see the IPs like on Nexus platform because I'm not redistribution HMM or HMM. Usually do that on Nexus. This is just going to show you the max, right? Now, you'll also see 3 and 4s because I've already configured the next version of this, which is VLAN aware and for the multi-home. So for the multi-home stuff is over here somewhere. Let me move this over here. So the multi-home stuff will be over here. So when we go to VLAN aware, you will actually see the 3s and 4, see what the purpose of the 3s and 4s. I'll go over that for you. But technically, we're just going to look at the 2s. So if we go show BGP L2 VPN EVPN, now I'm going to just do route type 2s because that's what we really focus on. Here's our route type 2s here. All right. So if, let's see what we got here. So as you can see on router 6, and I'm seeing it from the RD value, sorry. So the RD value is right here that we saw originally, which is 6888. And then here is 48 to tell you this is the MAC address because it's 48 hexadecimal number. And then here's the actual MAC address for one of the nodes. So if we go to router 3 and we do show interface E00, I could have did hardware address, but I don't feel like doing that right now. So we're looking for this MAC address somewhere. And if we look, so that's 3, so and there's 2 right here. So that's the MAC address that it sees, okay? And that MAC address is actually gonna go over to the other side. So when they try to ARP for it, again, you're gonna see 3s because 3s are responsible for bum traffic, broadcast, unknown unicast, and multicast, right? So now, if we don't do the route type and we just look at the table here, here's my 1s. These are all 1s, that's for the routers announcements. And then here go our 2s. And this is being shown from the, and it's a different one. I want to look, here we go. So here's the one for the VLAN base. These other ones are probably for the multi-home, but I'm not going to talk about that yet. So here's 2, here's 3. So 2 is probably H2. Let's just verify that. And 2 is H3, so this is probably, let's see, wrong. You don't want to put run in there. All right, so here's 3. So 3 is 2, and 2 is router 3, which is a little weird. So here's what I'm advertising here, and then we will see another one. Where's that at? This is coming from the other side. So that B00 is actually router 1 over here. And there you go. So that tells you that BGP EVPN is working, and I'm actually able to see the other side, right? Now, from a routing perspective, I do have EIGRP running. So if I look at my neighborships, you'll see I'm doing pairing with router 3 and 2. And if you look at the route table, we can see that I got my loopbacks being shown. And as you can see down here, here's the loopbacks down here, which is 10.8, 255.2, and 255.3. So if I try to ping from 10.8, 255.1, things are going to go through, and it's going to use MPLS as the data plane. Remember. And you see, man, went through. Now, if I trace route, since this is an L2 VPN, is the overlay, we shouldn't see too many labels here. So let's trace route in 8255 to make sure that's the right one. This should go right to like they're directly connected. Of course, this will take forever. There we go. So we don't see, like I said, we shouldn't see any labels because it's a layer 2 VPN. It's an overlay VPN. So you don't, the service provider network really doesn't care about what you're doing from a routing perspective, and you're responsible for the routing. I'm going to keep saying that because a lot of people end up buying L2 circuits and then they say, oh crap, we're responsible for the routing. And then they mess up some routing and then they're calling the service provider and they get mad when the service provider says, hey, we just give you the circuit, the L2 circuit, We have nothing to do with that. So always be careful, right? If you want to do a pairing relationship, do a pairing, and then they'll see if something's wrong with the service provider network. But if the L2 is up and your routing is jacked up because you did something from with a delay, or you messing around with K weights, or you messing with reference bandwidth views or OSPF, or you did some weird stuff like that, that's technically on you. So now that you see that that's working, we have reachability between all the routers here. You saw the adjacencies. So what we're going to focus on now is the bridge group. So if we do show run, I believe my bridge group is 8, but I want to double check here. So let's look at bridge. So yes, it's bridge group. So let's go to our bridge group, show bridge group, our bridge domain, but technically is a bridge group, but they don't use bridge group as the command. It's bridge domain. So if we do show bridge domain 8, this is just like VPLS, right? If you're doing VPLS, it's literally the same thing. Hey, where do I see these MAC addresses? So I see my MAC address here on gigabit 4 service instance 8. Same thing here, gigabit 5 service instance 8. And this MAC address, which is router 1, I see through EVPN. Now, you're probably asking, what's the difference between EVPN and VPLS? Well, lucky for you, I have VPLS running already. So I'm gonna go to router 4. We're gonna look at our bridge domain. Let me just make sure our bridge domain is right. All right, what is it? 9. So if I do show bridge domain 9, literally the same thing. The only difference is you have the VFI here, which is the virtual forwarding instance name. You have the VFI, and that's what I call it. So if I do show run section L2 VPN, and of course I fat fingered that, we are looking at this one right here. So VPLS BGP, that's going to have a VPN ID. Then we have since I was doing a Capella method, I'm not using the Martini method, which is I'm suppressing LDP for signaling. This is the command to do, this is the additional command you need to do under your VFI, and then your virtual edge ID. Obviously, they need to be different, right? I use 4, and I think the other router is 5, which is where you at? Run. Oh, down. It's down here, so it's probably 7. This out the way. Yeah. So it's router 7. So I went on router 7, and I did show bridge domain 9. Like I said, pretty much the same thing, right? So this is basically saying, hey, to get to that other MAC address, and this is the difference between point to point and something like VPLS, right? Point to point would be virtual private wire service. VPLS, it has to have a MAC to, um, it's called MAC to pseudo wire binding. So this is technically the pseudo wire here, technically. And it has to map the MAC to what pseudo wire, right? So it knows where to actually send it, right? And obviously VPLS is full mesh, right? So you look at VPLS and then you compare it to EVPN, pretty much the same thing, right? You're just different configurations, but ultimately they look the same when it comes to troubleshooting. And that is the second version of BGP EVPN service provider style, which is VLAN based. The next video, we are going to focus on multi-home. So you will see route type 4, which has to do with the designated forwarder, right? And that is very important because there's certain designs where if you don't do the designated forward correctly, or you do something like on the Nexus platform, if you're doing something like multi-site and you're using back-to-back VPC, there's certain connections that you have to make because of the way the designated forward rule works. This is Don from Padlock Technologies. If you like videos like this, don't forget to share, comment, like, and subscribe. Repost it on your socials. Bring people in and help grow the channel. I can keep doing cool stuff like this. And, like I said before, I am trying to be the mentor I wish I had when I first started out in the game. So again, hope you like this video. Thank you, and have a nice day.